Hey everyone, welcome to another deep dive. Today, super excited for this one. I have with me dawufi from Opacity. Welcome.
Thank you. I'm excited to be here.
Yeah, I won't summarize the project right off the bat. I'll let you kind of do this. But well, how did Opacity kind of get started? What was sort of the problem that you guys were looking to go after?
Yeah, it's an interesting, honestly, a relatively long story of our founders. I'll keep it as tight as possible so we can get to the juicy bits. But he's been sort of obsessed with this idea that the data that we collect and sort of live around in Web 2 is extremely powerful, extremely valuable. And that all the genesis of that started when he was actually looking at the Uber API, and he was helping a smaller project that he said was relatively successful at the time decide where to put Airbnbs in Chicago and sort of use Uber data as a proxy for like young, technologically friendly, like people were staying. This is a while back. This is maybe, I don't know, it had to be at least 7 or 8 years ago, maybe more. So he gets sort of obsessed with this idea. And then it kind of like gnaws at him for a very long time. He does a number of things between then. He buys Bitcoin. He ends up working at Demo for a little bit, and then finds zktls a couple years ago. The origination of it was a town crier paper, which eventually ended up turning into something called DEPGO, which ended up in the hands of Chainlink. And this idea of like zktls and verified data from the internet or the Web 2 legacy sources, whatever you want to call it, it's been around for a minute and he had been obsessing over it. But ultimately, he actually thought that there was these collusion issues and security and scaling issues that were completely unsolvable. It wasn't until very late last year, he was working on the Farcaster identity contracts, had sort of a breakthrough mentally on a way to use eigenlayer economic security to make it basically viable in his eyes. And that's the genesis of Opacity. And as far as the problem we're going after, there's a few different ways to frame it. But the way I like to frame it is really, we have all this data on the internet. We'd like to own it. But there's a couple problems. One is the gatekeepers, the walled gardens, make it very difficult, even when it's legally required, to even access all your data. And the second part is you can't really prove it or share it to anyone else. And that's a huge issue because if you can't prove you own a house, it doesn't feel like you own it, right?
Right.
And it's the same thing with like a Twitter follower account or maybe like a Uber driver rating. It's like you might have it and you might be able to download it and say that I have this, but if you can't prove it wasn't tampered with, do you really own that 5-star Uber rating or not? And we can get into the technical details and other interesting examples, but effectively, that's the idea, that this user-controlled data verification is extremely powerful, and we're already seeing that thesis sort of begin to play out today.
Nice. Yeah. So for people listening, like maybe we can just go a little bit into like what is TLS and zktls. Because like, we'll use your example. So you have over here like it's X. X is much easier to draw than Twitter. Won't try and draw the bird, but you have like the X API with your follower count here. And then you have like a smart contract over here on Ethereum, right? And we want to know the follower count in there. Would this be a good starting point?
It's actually easier if we just start with the regular Web 2 version, I think.
Okay.
So if we keep the right side, or whatever on the screen is my right side, if we keep that.
We'll delete this over here.
We'll come back to it is what we'll do.
Okay.
But you asked like what TLS is, right? That's called transport layer security. This was put in, I believe, back in the Netscape days. And I forget exactly who did it. But the idea was that they wanted people to know who they were connecting to on the internet. If you wanted to know that if you log into chase.com and you send them the password to your bank, or you log into amazon.com, you want to know that when you send your credit card information, that you're going to the correct server, that you're not just sending it to some random person who spoofed it or something like that. So they created this transport layer security, which is effectively what it does. There's a third party that sort of hands out these certificates, and you have a symmetrical key with between the client and the API endpoint, the server, right? So you want to draw a phone or a hand, person, computer, something like that. Yeah, that's me. It looks a lot like me, actually. And that works well. That works exceedingly well for.
This is so like whenever you log, so is it like based on login? So like you log in and you get a key, or you have
Yeah. So there's, I believe it's a Diffie-Hellman key exchange is the name of it. If anyone wants to look that up to see exactly how the math works, I totally encourage you to. I'm not going to pretend that I know the moon math behind the Diffie-Hellman key exchange, but there's a key exchange that happens. It's symmetrical keys, and it means that you're interacting with the correct party. This is a huge unlock, right? Like I was describing, this basically unlocked commerce on the internet, as well as a number of other very important things that we don't even think about today. And if you're wondering, am I using this? You are. TLS is the S in HTTPS. So anytime you see the S in HTTPS, that's what they're talking about. This is what makes the site secure. I think it's 95% of the websites on the internet today use this. So pretty much, I'd assume anyone who's watching this has seen the S in HTTPS, even if you didn't know what it means beyond it comes before the www. Okay. So this is where we've been for a long time. This is really good. But the problem is, if you think about
the way it would work, just to clarify, like if you requested something from X, you would like sign your request, then X would sign the data and pass it back to you, and it would be sort of tied together, right?
Yeah, and the way that it works is because it's symmetrical key, you can't actually prove to someone else that it came from there, because the data could always be fake, because you have the encryption key and the decryption key, right? So you could basically back in into fake decrypted data effectively. You can't prove it to a third party, but it came from X and X knows it came from you, right? So that's pretty good for the internet we know today and love. Okay. But as I pointed out, if I wanted to prove to you, if you call me up and say, hey, David, you're Anon on Twitter, I'd really like to have you on the podcast. Can you prove this is you? That's really, really hard to do. Up until recently, it was pretty much impossible. But this is effectively the way it works. So let's talk about what the TLS notary team is the guys who came up with the zktls tech that a few of us use in the space now. And what they figured out is you can sort of piggyback on that TLS security. This is where it gets a little bit more complex, because there's a few different architectures, I would say, to how to sort of prove this data out.
Let's use the opacity one.
I usually start with the other ones because I kind of like scoot through them.
All right, go for it.
Let me scoot through the other ones first, and we'll dig into opacity. So the first one is to just use a raw TEE environment. So a trusted execution environment. You could just basically insert a TEE in between X and little me and say, like, all right, we're going to trust that the trusted execution environment is actually going to do the key exchange. They're going to handle everything for us. And we're going to believe that Intel isn't screwing us. Their hardware is perfect. They will never be mad that users are taking control over their own data. These all seem like sort of really rough assumptions to build something scalable. Was basically.
I see you really like T's.
So there's a caveat here. We do like T's, and we do use T in the architecture. It's a great technology. What we don't like is security assumptions that aren't required or that seem suspect in the long term. And if you're going to believe that Intel is going to pick, users over protecting like Facebook's data, like walled garden, like we're guessing that the larger companies tend to sort of aggregate together is one direction. And also there's been some serious security concerns with TE already. I know there's some projects are addressing them, some projects are not, but it's tough without some sort of added security to believe that that's going to be the end game. That has been, I don't know, if that's the end game, everyone just does everything in TE and we don't need to worry about anything. And it seems like a bit of a farce.
So basically the T would grab your request
and basically just serve as you between X, right? And you have to trust that they're not accessing any of your information, or there's no one nefarious running a TE for you, whatever it may be.
Yep.
So that one's a little bit rough. The second one is called a proxy architecture. Proxy architecture is interesting. It's a little bit similar, and I'll be blunt. I know less about this than opacities, but I'll do my best to explain it. But effectively what you do is you send the request out to a proxy server, and uses the TLS notary tech instead of just the TEE. But there's a couple of problems with this. And this is sort of where, well, this is one of the places where our founder got stuck initially. The first problem is you have a set of, proxy servers sending out these requests to, Twitter, Facebook, whoever, to verify private data, right? The privacy is not a concern there, but if you have, like, what's mass adoption look like? 1 million people, right? Like, if 1 million people are sending requests through a small number of servers to Facebook, all to verify their accounts and their data, it's an extremely easy choke point to sort of cut off. Now, legally speaking, this is all new territory, so there's no way to know for sure. But our rough guess is that the trillion-dollar corporations who have their entire value prop or their entire sort of revenue stream based around controlling people's data, they're not going to be happy with people being able to verify it to third-party sources. And it's fairly easy to cut off a proxy that's not really a user. Like, the user can still access their data. You're blocking a third-party service, right? So this is, again, a little bit difficult to see how it scales effectively. There's a way to go around it.
Like going through a VPN.
Very similar. Correct. Yeah. And that's why VPNs get blocked all the time. So exactly. It's a great example. There's a way to get around it where you source residential IPs, but to be blunt, that UX kind of sucks because the way they work is you sort of like, you're using like backdoor code into like random apps. So like if you have some like dumb flashlight or calculator app, there's a good chance they're selling that service of being on your phone to a residential IP company, so they can source you and sort of run traffic through your phone. One, it's just feels a little icky. Two, the UX again is terrible. We've seen connection rates about 50% from when Hirsch tested it out, our founder. But the biggest problem is if you think about the residential IP, if you draw a little house in between proxy and X, what we've got now is exactly the issue that we had originally in the TLS. We are now susceptible to a man-in-the-middle attack. Right. If little man on the right side, I'm using my mouse on the screen. I don't know why I'm like pointing at you. If little man on the right can figure out, and we've seen it possible, which little house he's working with, then he can fake the data because he has the encryption data key. The proxy will see everything come through because the proxy gets encrypted data back and forth, right? The proxy does not actually see the real data that's coming through, but you can convince the proxy that you sent out. You basically, what you can do is you can send out a request to prove I have $1 million in my bank account. It's going to go through the residential IP and back to chase.com. Then when chase.com sends it back to the residential IP, if you can figure out which one that is, you can swap it out and encode it so that it looks like a real response from api.chase.com. Send it to the proxy. The proxy thinks it's real because the encryption looks correct. And then now you have a generated proof that that's exactly what's going on. So it's difficult, but if we're believing that this is sort of the future or the frontier of where a user-owned internet goes, then we don't think that risk is one worth taking. So I'll pause there for a sec because that was a lot. But these are the two ones that Opacity does not use. I think it's to be fair, there's trade-offs.
You need kind of two pieces of the key to sign off on the data, right? So there's like two parties in here. There's you making the request. And then there's either X or a T, or like the structure here. So if you could compromise which one of those, then and yourself, you could fake the data, which is a problem.
Correct. Okay. Correct. 100% correct. I will be fair. The other ones are easier to implement than ours, for sure. The other ones, especially the TEE, they are easier to implement for sure than the way that we approach it. So there is an ease and speed there today that our architecture doesn't have. I want to be very sort of open and honest.
I mean, teas. Like I've had a couple of people on the show who've used teas, and it's always like if you assume this black box works completely correctly, it really solves a lot of our problems. And you're like, it's like, I feel like you're yeah, just really
too,
being hopeful here.
yeah, a little too much magic for me. I love the magic, but a little bit too much for me. But that being said, there's upgrades coming. ZK Tech's getting faster, so we're confident that prioritizing the scalability and security is really the way to go. And we're gonna be getting proofs down to under a second. So I think the call here is that, like, as long as it's a good UX, it doesn't matter if you're like thousandths of a second or hundredths of a second in the long term for these types of things. It's sort of the rough idea. But that's it. Let's get into Opacity's architecture. So what Opacity uses is called an MPC architecture, and you're going to have to draw a bunch of little boxes for this one. But effectively, the way that it works is, and there's a couple of tricks here, and we can get into exactly what it is. But the idea of MPC is a multi-party computation, right? So you say to yourself, like, okay, if like one node can collude, like, wouldn't it be faster to just have like 7 different nodes do the run the ZK proof together? And then you're pretty clear, because it's much harder to collude with 7 nodes than it is with one node, and you get to like whatever impossibilities, like, you get to the impossibilities of like guessing someone's private key, right? And like it's good enough. But the problem is the proving time doesn't scale linearly. And this was actually the point where our founder Hirsch got blocked, because if you just have one node, it's very easy to continuously basically ping the network, wait till you get the correct node. Well, what are you gonna have? 100 nodes, 500 nodes? Like what? Like how many Bitcoin nodes are there? Eventually, you're gonna get the right one, and you can prove anything that you want, which makes the network completely useless.
That would be like changing out the house for like just some random person.
Exactly. Yeah, with no proxy in between. You could just keep hitting it over and over and over.
Yep.
So there's a couple of things. The multi-party, like multiple, like huge number of parties, doesn't work because it's very slow. The other thing that can happen when you're having multiple parties do the same computation, especially for data that can change, doesn't have to change frequently, but it can change sort of without your knowledge. So if you think about your bank balance, right? Say you want to prove I've got $100,000 in there, and you happen to not, you weren't thinking it through. You try to prove it on the first of the month, and halfway through that computation, your rent hits, and now you've got whatever $97,000 in your bank account, right? Whoever in that process, in those nodes, tried to prove before that you had 100,000, they're going to come back all verified. Everyone after is going to all reject it. You're going to have a split quorum. No one's going to have done anything wrong, but someone's going to get slashed, right? In a sort of economic security model, right? Because it could be one person, and it's not even clear who's right or wrong, because
put some timestamps on this thing.
So we do use witness, and that helps, but it's still a difficult thing to prove, because the timestamps don't like, what do you do? Just keep rerunning the proof, like you can't like bake the timestamp into the economic security, at least the way we have it structured today. So that doesn't work either. So while Hirsch was working on the Farcaster identity contracts, he figured out this trick where you can sort of inherit the Sybil resistance of the Web2 legacy platforms, where you use a static point of data like a Twitter account or a social security number or whatever makes sense for your product, right? Because these proofs aren't really shared between like companies, right? It's all user controlled, where effectively you do that, and then you can switch back to the 2-party compute. It's still MPC, but it's just 2-party, because you can log the attempts. And if someone tries too many times before like doing a verification, you can effectively block them out. And exactly how many proofs you want to let people do, or like if you just want to, ban someone immediately, or there's some reason to like give them some leeway because like things change, like your bank account balance. Like if 1 goes wrong, it's fine. If 5 goes wrong, it's bad. That's totally up to anyone who's using our network to run the proofs. But ultimately what it does is it lets you use this MPC architecture, not have to have everyone compute it, and it allows projects to kick people off the network who are bad actors without risking the
You'll
economic
send it
security.
here. It'll basically, there will be the peer-to-peer network. Everyone will say like log, hey, he sent a request. One of them will get it and then do the passback architecture, but everyone will have logged the attempt. If he does it too many times, everyone will be like, hey, he's trying to fake the network.
Yeah, and it's important. Yeah, and the first time you can have, and this is also optional up to who anyone wants to do it. You want to have 7 people, 7 nodes run the proof together, and it'll take a really fucking long time. But you have like, you're giving out $1 million Bitcoin loan. Go maximum security. You're just proving what did someone listen to a song on Spotify? You can probably skip the Sybil resistance altogether. Like no one's going to fake a Spotify listen, right?
You have like your request and then also the number of nodes that you want to run it, right?
This is all like hypothetical stuff that you could do in the future. So
yeah,
the way that it works effectively is like first you can prove the Sybil resistance. It comes back. That user is like now tied to that account in some project's network, not opacities. Again, with the ZK stuff, we don't actually see any of this. Yeah, I feel it's important to know that because some people think like, oh, like I'll just come to you and I'll scrape all the data you have. Like we don't have any data. That's not how it works. You have to have your own users, and you have to have your own. You have to have your own database or blockchain or smart contract that's utilizing the data. We're not just a repository of credentials. Right. We're the piping that moves it back and forth. But yeah, that's roughly the way the architecture works, and hopefully that was coherent.
Yeah. So then basically you would have your request like what's my bank account balance,
yep.
And say like I want 5 nodes to go ping the chase.com server with this encrypted data. They take your encrypted data, ping it back, send you a TLS notary proof that says he did this, and then would they ZK it, or you would have to ZK the proof?
So the way the ZK is a bit of a misnomer compared to how other ZK works in this space. There's 2 important parts of the ZK here. The first part of the ZK is that the notary, the proxy, the TE, whichever one it is, they never actually see the raw data, right? That's one part of zero knowledge that's really important. That like if you're proving your bank account balance, you're not trusting some node run by something.
Okay, this has nothing to do with the normal T thing. Or the normal TLS. This is all ZK architecture where you would have.
Yeah. So it's not the regular TLS. We're sort of piggybacking on top of it, right? Mm-hmm. So this only works because TLS exists, right? If you couldn't already tell that you were talking to a specific server, then doesn't matter. Like anyone could switch out the data, right? It only works because this system exists, and then we piggyback on that security. So the quote unquote man in the middle who could theoretically attack, they never see decrypted data. They only see encrypted data, and that's really important for proving private information. The other part that's really important is the sharing, right? So these proofs that get kicked out are encrypted, and they are not the actual data. So when you send a proof, you're not sending, I have $100,000 to someone. What you're sending is, hey, you asked me if I could do this request, and I have successfully proved that I could. And it's like a slight difference, but it's really important if you think about what companies want to know about users, right? Because you might not necessarily want to know exactly what a user's credit score is. You might want to know it's over 750, right? You might not want to know if a person works at Google, but you might want to know if they've ever worked at Google and like prove like through Rippling data or something like that, right? So you're not proving the exact payload response to whichever app is using opacity or one of the other networks. What you're proving is that the user asked for a request and they sent it back. Now, if the request is extremely specific, like, do you have a 4.7 star rating on DoorDash? Then it's pretty obvious that, you can inject that trust into your network, but that's fine. That doesn't necessarily need to be private, right? You might want some of this stuff to actually be public. I would love for people to know my Uber rating. I'm very proud of my Uber rating. I'd love to have an NFT, soulbound NFT that does it. I would much less rather have a soulbound NFT that has my unencrypted social security number. But there's flexibility there. I think that's the other part of the ZK. But this doesn't really have to do with like ZK scaling or some of the other ZK topics that you see out there.
This is more like the Tornado Cache ZK.
I don't want to be called Tornado Cache, but
Come on, Tornado Cache TLS. This is. Well, I mean, like, so I'm actually aware of how Tornado Cache works a little bit. So, like, to me, it makes sense. Like, you're proving you have a balance in this pool without telling which balance is yours. So you come up with some sort of nullifier that represents where your deposit was, but it's a big long hash. You upload that to the program. The program verifies, yes, it's in there, but it doesn't reveal which one is yours.
To be clear, that analogy is good. I just don't want to be associated with Tornado Cache.
Yeah, no, I get it. But yeah, so in this way, you would upload like, listen, I made this request to chase.com and it came back signed here, and this is what it's proved. You send that off to them, and then they know. I guess the big question here would be like, do the ZK nodes know this guy's key then? They would know that what his notary key is?
No, they don't know the keys either. So this is sort of the magic in the research that was done, so that it is totally
Nice.
Oblivious in nature from the node or the proxy standpoint. There's nothing they learn about.
So it's not like chase.com has to take part in this.
No, and that's one of the big ideas, and the framing that we often use is, we're sacrificing cooperation from the corporations and replacing it with cooperation from the users. The only thing that you need here, if you're an app developer, which is usually the audience that I try to speak to, is you need a user to log in, right? Because you need the user to be able to actually access the data that you want to prove. But beyond that, you don't need anything, because theoretically, just to get into the technical weeds a little bit as best I can, if Chase, api.chase.com or api.x.com, if they were willing to sign data, then you would have a signature proof that it came, and great, you don't need us at all. We become immediately irrelevant, to be honest. Yep. But to take that bet long term, you'd have to guess that Facebook, Twitter, anyone who holds data that they find valuable is willing to basically give it away for free, or that users are willing
to. This was the old API 3 model that they wanted. API 3 is an oracle, and they would just try and partner with Coinbase and with these data providers to just sign it with a ETH key, and then you could pull the data in directly.
Turns out the incentive structures don't really work out particularly well for that. I've met with API 3 guys. I think they're really smart. I like them a lot. I try not to talk too much shit. But if you look at it just from a first principles perspective and like what's gotten done, like, sure, that'd be great for the user everywhere if you could prove your data. Turns out there's a lot of money to be made from not letting users prove and share their data. And to be clear, I don't blame anyone for following the incentives. I very much believe that it's crypto's job. And one of the reasons that I love working at Opacity is, like, if you want to make the world better, like, you have to change the incentive structure. You have to change what's useful and helpful to people and what they're able to do. And if you can do that, then you can sort of like rewrite the rules on how business is conducted, how data is shared. There's a lot of downstream effects that we can definitely talk about more. But this is the crux of what's going on.
And then, so now you get returned the zero knowledge proof, right?
Correct. Yeah.
And now the big question is, how do we get it over to Ethereum land in our
smart? So there's a couple different ways to do it, and we have some partnerships with groups like Align Layer and Lagrange that are going to help with this. So I don't want to harp too much on their tech, but effectively, what happens?
By the way, you need to give me some intros so I can get them on.
Oh, I'm sure they'd love to. Yeah, Ishmael is fantastic. I work more with the marketing lady at Align, but I know she's fantastic. but from what I've talked to the team, they're great. We can definitely hook that up. They're fantastic people, and they've got some. How do I put this? My barometer now for if someone's tech is good is whether or not it impresses my founder, because I don't have a better barometer than that, and they've managed to severely impress them in a good way. So it's important to remember again that these proofs end up on the client, right? So with us, we target mobile APIs pretty much exclusively. I should touch on that just briefly before we before we leave. There's two really important parts to targeting the mobile APIs. The first one is the consistency and ease of decoding of the response about server-side HTML and like a web browser. It's actually really easy to break a proof. You just sort of change something on the website and then your proof won't run correctly anymore, right? If you like took the bank balance and moved it to like a different page, like it's just gone, right? So that's an issue with schemas over there. But you also get a persistent OAuth on the mobile, which is really nice. If you think about how often you have to relog on Twitter on your computer versus how often Elon asks you to relog to Twitter or your phone, it's like almost never. So that makes it a much better UX experience. But that proof then goes to the phone, to the app that's integrated our SDK. And actually what happens with it there is we're totally agnostic too, because we've done our job of verifying the data. And we've seen a lot of projects actually who, they're not like crypto native. They're not really like their users are not interested in wallets and like figuring out which chain their USDC is on. Like they just like want to like, do a quest and get paid for it, or stitch a TikTok video and get paid for it. And if you, for your V1, just want to dump it into an AWS bucket, like feel free. Like if your users are good with that trust assumption and you're good with that trust assumption, that's fine to start. I think a lot of the stuff will move to the protocolization direction eventually, just because the efficiencies. But for day one, to make sure you've got PMF before you start doing all that deep cryptographic work, that's fine. And I think this is a lot of what Web 2.5 really should look like, where it's like there's crypto rails like opacity to do something that theoretically was not possible to do before. And then after that, you pick and choose sort of which parts of Web3 are most useful to you. But using that proof, you can do a lot of different things. I think the biggest thing that we've seen so far from our partners who want this to like inform some sort of like protocol reward or like, mining efficiency or like whatever it may be, they're just like sort of minting soulbound NFTs for now. That is the easiest way to like prove that you've got something and then you have it on chain. This works really well for like for proofs that like are static, right? So if like I prove that I once worked at Google, that will never change. So I can have like a badge that says, former Googler or current Googler. Like if you do the timestamp with witness protocol, those work really well. For stuff that changes, it's a little bit more difficult, and probably you can just have it be like the input to a smart contract. So the best example I have for that is, maybe in the DeFi space where someone wants to give a better lending rate if you have a credit score over 800. When someone's, you can say like, okay, I want to do this loan. I have this credit score. Let me pump it into the smart contract and it'll kick out like, okay, this would be your rate based on your credit score. And, the smart contract doesn't see exactly what the credit score is. It'll just see like a range or something like that. But that way you can initiate the loan, at least at a certain point in time. You're good for that rate at that time. And just like, if you were to get a mortgage or something like that, if you wanted to do it again, you'd have to reprove these things. And I think that's a good analogy for sort of whether you'd want something like extremely Lindy, where it sticks around as a proof and like you own it in your wallet, versus it's an input to a smart contract and you're going to want to check it out every time you use it again. So hopefully that made sense.
Yeah, no, it definitely does. The big thing, I guess, would be, it kind of looks like an oracle in some ways. You can read this, but it's a lot different than, say, like a price feed oracle, because it's probably going to be a lot slower, first off, and then
no, I was just talking with someone about this yesterday. They're building something that has like very fast sort of social betting and stuff like that. And I told them straight up, I was like, I don't think you guys want zktls. And it's the same thing as like when people are like, oh, blockchains will be as fast as like an AWS. It won't ever be. Centralization will always be faster. So if you need maximum speed, go talk to Jeff. We're not going to beat that. There's other stuff that comes with it though, right? So the first thing that comes with zktls versus an oracle is obviously the zk aspect. But again, if you're working with public data, like a price feed, who cares if it's zk? You can just go to Boomer. No one cares, right? So right. Price feeds, so I'm actually very bearish on price feed oracles for zktls. I don't see the purpose. Also, because of all the tech involved, it is probably always going to be slower, is my guess. I don't know that for sure. These things change frequently. But I see no reason if you need maximum speed to use zktls for this stuff. But you have the zero knowledge. So if you're trying to prove something private, or if you want to bet on some private level of data and not reveal what it is, zktls is the way to go. Or if you want to access data that isn't public. So it's if either something you don't want to be made public or something that is inaccessible by the public, that's where zktls can look a lot like an oracle, but serve like a slightly different purpose. The sort of meme example that I use very frequently, I think my founder actually wants someone to build it. I don't think it's a business, but I think it'd be very funny. It's like to be able to go into a Telegram chat and like bet with your boys who's going to get more Tinder matches that week. And you might not want to reveal exactly how many matches you got. You might feel a little bad, right? And there's definitely no open API where you can just like see how many matches you and your homies got like on a scoreboard on Tinder. I think that would probably tank their stock price. It would be a brutal feature to launch, but it would be like a funny thing to do. And I think it represents the idea well that like there's no other way to verify this data to like put economics incentives on it, which is really what a lot of crypto is about, right? Like being able to add economics incentives to data. And then also you don't really want to reveal it all the time if you had a bad week. And listen, we all have cold streaks, right? So that's where, sure, in a lot of ways, if you look at that example, it looks like an oracle. But right. The zktls tech, you're actually doing something quite different on the back end. And then it allows for something quite different on the product side or the UX side or the user side, however you want to frame it.
Nice. Cool. So 4 attack vectors on this thing. The first one would be, like the other piece, most of the time with an oracle, you would want to crypto economically secure it in some way. Correct. To say if he lies, he's going to, lose a bunch of money. Here, the people that could potentially lie would be like, first it would be like the X server, right? So like if they just sign bad data because like, they have no stake in this whole crypto game that you're playing. Like the dude in charge of the API over at Twitter, he'll do you a solid and sign one, right? Or like what's sort of preventing that, or is that just something you have to handle in your use case?
Yeah, so I'll speak about opacity specifically in this regard because it'll take too long to do all 3 every time, I think. But hopefully my answers for opacity sort of make sense so that it all sort of tracks for everyone for the different architectures and stuff. But really, you're sort of relying on just regular business incentives for the first attack vector that you mentioned, which is, if I've integrated the opacity SDK and I'm trying to prove an Uber rating, or let's use a bank balance because it's a little bit more aggressive. The request is coming from a user's phone, right? And it looks pretty much indistinguishable from an actual request from the Chase app. So for them to start faking data, they'd either need to be able to detect it, which, I guess sort of trust us, right? That they won't be able to detect it. But you could see how if a request is coming from a phone, it'd be very difficult to detect that, right? With, proxy architectures and residential IPs a little bit harder. But even then, it's like people access things from different IPs all the time. If I travel, right? Like I'm using my phone, it's a different IP, it's hitting a different cell tower or something, but it looks like the phone because it is. For them to start faking signed data or signing bad data, they'd effectively ruin their app, right? Like if every 100 times I logged in to Chase, it randomly showed that I had the wrong bank account balance. It's completely fucking useless. So you're relying on them needing to actually have a good user experience for everyone and not send bad data to people who are not using zktls to prove everything. So based on that, we think it's a pretty safe assumption that they're not going to start signing bad data. You mentioned economic security. I will add, as far as I know today, at least, we are the only eigenlayer AVS that is using this technology.
Guessing it's these guys?
That's those guys right down there. So we use economic security to ensure, very similar to an Oracle, that there's no malicious actors, or at the very least, it's economically wise to behave in the proper manner and not sort of try to attack the network.
And this would be based on like the number of requests, right? So if somebody is trying to find a colluding node and they're sending like bad data to ZK and the node colludes with them, we would be able to tell because everybody else failed that guy and he didn't.
Exactly. Yeah. 100%. And then you'd also burn the account with that Sybil resistance that I talked about in the beginning, so that that person could no longer, or at least, how should I put this? There would be a log on the network that this guy is a bad actor. Now, if someone wants to launch an app and not pay attention to that, we can't stop people from accepting proofs. It's all happening on the client side. It's all decentralized. Opacity is not here with a blacklist being like, we don't like OX, blah, 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 blah. They're not allowed, right? Like, we can't do that. But what we can do is we can create a log of these proof attempts and say like, oh, this person has attempted to collude in the past. That's on the network. As an app developer, you can say, great, I'm glad that I know that this person has tried to collude in the past with some other app. I'm not going to accept proofs from this address. And that's sort of the way that works.
But it would be very subjective as far as the slashing goes, right? Like, not either. I don't know.
Yeah, I mean, we're close with the EigenLayer team. Obviously, EigenLayer, I believe, is still figuring out slashing exactly as far as I know. So early days for all of us. We're early. For anyone watching and you're wondering, we're still early for sure. And there's a lot of math that needs to go into that to figure out exactly what is the most efficient way. But we know slashing works from other systems. We just need to figure out exactly what the right one is for ours as well, because we have a very different architecture than even most EigenLayer nodes, right? Like we're running something pretty differentiated. So we're being very cognizant of that. There's 13 nodes running right now, if anyone's curious. So we're below the threshold to get listed, but like technically we're mainnet. And we're waiting for some more upgrades and to figure out some of these things before we go fully to prod on the AVS side. But this is the way it's built and what's being added on right now.
Nice. So is this a chain, by the way? Did you guys are you guys using a chain, or is this?
No, it's just the AVS. There's no chain. There's no token. To anyone in my Telegram asking me when token and where they can buy the token, or if they can list the token, no token. But that's really important for us, again, for that whole like Web 2.5 thesis, where to get very concrete, because I think concrete examples tend to sort of resonate in people's minds a little bit more. Like one of the companies we're working with is called Daisy. And what they figured out was Gen Z influencers are out here like splitting brand deals, basically. Like, hey, if you stitch this video, like it gets a certain amount of views, I get paid like per view count on my brand deal with like Ferrari. So if you get me more views, then I'll like give you a cut of like this revenue. But that's really hard to prove. You have to trust that the person who's getting the money from Ferrari is actually going to give you the money afterwards, right? It's extremely cumbersome. It takes a long time. None of it's verified. But they've turned it into a platform. And, they're adding more crypto as they go along, like, crypto payments and stuff like that. But at the end of the day, like the vast majority of Gen Z influencers do not care about a chain. They do not want a token. They want to stitch a video and get paid for it. And because of that, there's no sort of token or anything required. It's all crypto tech, but it doesn't require, the wallet pop up or anything like that. All the terrible UX that I'm constantly griping about in crypto. People are like, why don't we have mass adoption? Like, because this is a terrible product. Like, I'm glad we're all working on this together to make it better, but like empirically, it's bad compared to like what's out there in Web 2. And I think like giving the flexibility that zktls does, as well as like pushing the boundaries of like what's possible, it's like getting us much closer to like a consumer wave that I think is going to be sort of blowing up well, it's happening now, but I think it'll continue to happen over the next couple of years.
Yeah, no, I mean, the last few videos I've done have been on kind of like social reputation stuff. So like you could have like on-chain, but it's based on like your reputation, based on your credit score and your Twitter followers and your Farcaster account. And so you lump it all together for a more cohesive sort of social reputation score for, say, doing things on chain or having a decentralized social media. And I could see something like this being pretty valuable in those contexts too.
Yeah, I'll give a bit of a hot take that like I'm not a huge fan of like the effectively like re-centralizing identity, if that makes sense. Like it just doesn't, it never felt like sort of like the resonant way to do things for me, because if you think about what companies who like pay for data or like when you're proving something, like it's very rare that it's actually really useful to have some sort of central repository of something. Usually someone's looking for something very specific. So again, this is sort of a call out to the devs who are thinking about using zktls or want to work with Opacity, and DM's open. Feel free to hit me up. I'm always happy to like jam on ideas. If you go back to first principles, like like maybe you just care about the credit score and like you don't care about their Twitter follower account, or maybe you care about their purchase history on Amazon, but like you don't really care where they live, right? Like there's all these different like weird little things where like you can sort of make your product simpler, you can get more granular and like really sort of get to the heart of what you're trying to understand about your user versus like the sort of what I would call old way of thinking where like 18 to 39-year-old male in the Midwest of the United States like doesn't really say a fucking thing about me. You know what I mean? Like
Yeah.
compared to the type of data that we can get. And I think for a long time people have really said like, oh, on-chain data will be better. But like the fact is you don't want everything on chain. Being able to very specifically target what is the important thing about your customer or your user that you'd like to know and prove and verify to inform what you're doing on your protocol rewards, on your airdrop, on your social credit scores, whatever it may be. Because tech like this exists, I expect what I call sort of like positive fragmentation, where you'll just reveal what you want and need to each project, as opposed to having some massive wallet with like everything you've ever done, like coagulated into some like you're an A+. It's like it seems less useful to me than the other direction. Like if we're going to believe in decentralization and that user control is good, I'm much more bullish on the idea that like that it'll be sort of fragmented in a good way so that you can work with what you need where you need to. Now that's not to say there won't be like data hubs that like sort of sell access to data and stuff. I do think that sort of makes sense, but I think it's much more likely that you'll see like a healthcare hub, right, where everyone can import their health data and like kick out, some like insurance premium reduction, right? Or like a driving hub where like it gets your Uber data, it's got like your telemetrics from like your Tesla, and like it's got your I don't know, your insurance app that tracks how fast you drive, and then like okay, now car manufacturers want to like access that to like know how their drivers drive and like who they should be targeting for like a new car that's coming out. So I do think there will be some aggregation, but the idea that there's just pipeline everything through zktls from you throughout the entire internet and like have it in one place so you can sell your data personally to everyone, like people just don't like doing that. It's just like it's cumbersome. Like I don't think it'll go down that way. But
The only person who'll go through with that is not the person's data who you want to buy.
yeah, very frequently, exactly. So maybe a bit of hot take, not Opacity's official stance, just trying to add some of my personal color to the pod.
Well, it's the same with a lot of people like who farm tokens. Like the people who are out there farming your token are probably the people you want least in your community. It's like,
Yeah.
it's just backwards.
And I don't blame anyone from farming tokens. Like you put the like you meaning the developer
Right.
put the financial incentive there, and now you're gonna be like, oh, they took their TVL away after they took my free money. Man, that's charity. Like that's not. There's always
Yes.
PMF for free money. It doesn't have anything to do with how good your product is. It doesn't have anything to do with how sticky your customer base is going to be. The one thing you can learn from like airdrop farmers is like, is your product any good at all? Because you'll get 100,000 people to try it, and I don't think that's worth nothing. But to your point, people frequently come to me and they're like, oh, we're targeting like whales. We're going to do an airdrop. It's like, really? You got enough money to incentivize a whale from an airdrop? You don't. You don't. So who are you actually attracting? Who are you actually talking to? Right. I think we miss the forest for the trees a lot in crypto. And it's like, I think we'd be a lot better off. I'm seeing a lot more of it now, which I'm bullish on. Like dial it back. Who are the people you want to attract? Who is this helpful for? Who's willing to pay for this? Because it's a good thing to get paid for a product. I don't know. We lost track of that somewhere too, where they're going to pay you a certain amount of money and they're going to get more value back from that than before. And zktls is really a huge part of that because you can make products so much better, right? So much more personalized, right? And just more attractive to the right people that you want to attract because you know so much more about them. You don't have to just blast it off to 100,000 people and see what happens. My running joke is like, I promise you Nike would send free shoes to everyone who spent 10 grand on Adidas last year. But like, how do you prove that? But now you can. And it's like, okay, good. Like now we know who this app is actually for. We'll give them money. Or we can reward people for bringing them in, right? And sort of, I'm really bullish on the sort of referral model for zktls, where like I might not like buy a shitload of like Pokemon cards, but my friend does. And you have a platform for Pokemon cards, like, yo, give me $100 to get him over here. Give him $1,000 because he spent $100,000 on it last year. And like everyone's happy, right? Because you can clarify the value chain a lot better with zktls. So I don't know, a bit of a rant, but hopefully.
Yeah, I mean, one thing I want to do, like with this architecture, does it sort of fly in the face of the grander vision that we have in Web3? Because I mean, like what you would say is like, if you talk to a decentralized social media person, they would say like, listen, we should eventually be decentralizing X, we should be decentralizing Chase. And then like all this stuff is its own chain and it's already verified. And like, we don't need zktls because everything is going to be sort of verified in and of itself. Or like, what would be like the internet redesign if you were going to use opacity or if it was up to opacity?
Yeah, I've got thoughts. The first one is like, I've been a maxi before and I'm kind of over it. It's never like, I don't know, maxi's shit is fun for like spreading memes, but like, look at the history of the entire universe. There's always variability, right? There's always different ways to do things. And another one of like my running jokes is that like when Ford made the Model T, like he didn't reinvent the wheel, right? Like it's like new ways to use things. And like the choice is what's really important for me in decentralization, right? The ability to exit a system if it's not beneficial to you. That's one important for the user, obviously, because they're in a system that's not beneficial to them, but they're taking advantage of. But it also holds company and products accountable, right? Like if there is a way to port your entire Twitter social graph over to Farcaster, now Twitter has a much higher bar to clear to actually keep people around. And that's a good thing for users. That's a good thing, like sort of roughly for the world is my take on that, right? And like horses are still around too. They've changed their use case, right? Cars didn't replace them. They're still trains, you know what I mean? But when you give people optionality, it's just broadly speaking, the way that you can sort of discover what's helpful to people and what's not. And that's sort of like the part of capitalism that works really well. I don't want to get on my soapbox too much about these things. But when everyone was like, we need to decentralize everything, I'm like, nothing's ever been everything. It's sort of like proof of humanity is dumb. No one's marketing to every single person in the world. Like everyone has an audience that like their thing works well for, right? And does it, back to your original point, does it like fly in the face of the dream of Web3? Well, like, yeah, I'm very happy to fly in the face of some people's dream of Web3 because I think they're patently wrong. And I'm sort of unwilling to acquiesce just because someone has a dream of decentralizing everything so they can be a self-sovereign citizen and live in anarchy. They're like, I don't think that's good. I'm not going to help you. What I will help you do is like, if you want to go do that yourself, go off, King. Like, feel free. Like, I don't have to live. Like, part of the point is like, I don't have to live in your crazy anarchy world. And if you want to port all your data and put it on chain and leave your social security number out there, I think that's an option that people should have. I think that's how you learn lessons, by doing crazy shit. But I don't think they should impose that view upon everyone else who's like, I like Twitter, but I like Farcaster too. And I'd like to have my graph in one place, but I'd also like to be able to like reach grandma who doesn't understand what a Diffie-Hellman key exchange is, or whatever the use case is. And I'm not saying Farcaster won't get grandmas. My point is that there's different audiences, and being able to move around where you want to is really, for me, the crux of decentralization, to give sort of an alternative to centralized like extractory markets, and disrupting them, so they either get on board or like get the fuck off.
With that's pretty good. Anything I missed? Anything we need to cover that like there's like, oh, you missed a giant piece of our architecture?
No, I think we did pretty good. I do like the way the diagram ended up, because this is sort of how I think about opacity, which like it's all this crypto shit by itself, and then like if you wanted to go to ETH, you can, right? That's really sort of like the crux of my argument as I talk to people, because as I speak to more and more, like especially consumer companies, it's like I don't want to have to choose wallet providers. Like I don't know which way account abstraction is going to go yet. Like I don't want to choose a chain today. Like I don't want to get dogmatic about like mega ETH versus base. Like I just kind of want to build something for people, and we'll get there eventually. Like this is the way I think about it. This is the way I think people should think about it. And having it sort of modular is again back to my point that I was just ranting about, that like that's part of the beauty of crypto. And that's why like I love zktls, because it couldn't be built anywhere else. You needed the crypto economics to build what we built. And then at the end of the day, this gives like developers the choice to live fully on chain or just give users verified data and build something great that way too. So no, I think this was good. I liked it. I'll say this. I enjoyed talking to you, Fett. So I appreciate it.
And where can people find out more?
Yeah, I guess for call to actions and such, we announced our raise last week, and alongside that, we went live with the demo app. So opacity.network is the website, and if you just want to go straight to the demo app, it's app.opacity.network. We're Opacity Network on Twitter. We're /opacity on Farcaster. I'll be blunt, that's where me and the founders spend a lot of our time. So DMs and DCs open everywhere though. I'm on Telegram and Twitter, wherever. I'm at dawufi. If you want to build something, if you have questions about what you can do, I would love to talk to you. Please reach out. A lot of my job right now that this tech is in the wild is figuring out what people want to do with it. We talked about bank balances. We talked about Tinder. We talked about a lot of different things. But I'll put the call out there because all of our best ideas, like the influencer one, the DoorDash one, you can kind of see coming. But like we have a guide disrupting like the earned wage access market where you're verifying salary data to get access to your wages early, which is like a massively predatory market that you can make so much better with crypto rails now that we have zktls. This is like shit I would never have thought about. So the cool stuff is definitely coming from the community. So highly encourage anyone who has an idea, jump in the Telegram or reach out to me. I'd love to talk to you about what you're trying to build. And I'll tell you I hope it comes across that if I don't think it makes sense, I'll tell you, because I think that's like the good thing to do for people.
I got some good ideas. So I'm going to follow up with you. And then, and then you got a podcast too, which is Vibe Checks.
Yeah, I actually just
I listened to it. It was sweet. So
thanks, brother. Yeah, I actually just put it on hiatus a couple days ago because I've been so busy with the zktls stuff. It also started as like a Farcaster coded podcast, and then Farcaster started like fragmenting, where like the original idea just didn't make sense anymore. So Vibe Check will be back. It's it's go to market. It's vibes. It's just like checking in on people and seeing what's happening in the world. It's a little bit laissez-faire, but yeah, it's been a lot of fun, and it will be back.
Thanks, man. Well, thank you so much for having me on. And yeah, talk to you soon.
Thanks.